Now, law of radioactive decay. Okay. Now, suppose at some instant t, number of undecayed nuclei in the given element, that is n. That is n. And in time interval delta t, the number of nuclei decayed, that is delta n. So delta n by delta t, that is the rate of decay, or we can say that is the number of nuclei decayed per unit time. So that delta n by delta t, we can observe this thing experimentally. It depends only on the number of undecayed nuclei. જે અનડિકેડ ન્યુક્લિયાઈ છે એની ઉપર જ ડિપેન્ડ થાય, ઓબ્વિયસ છે. કારણ કે જે ડીકે થઈને જતા રહ્યા એને તો હવે ક્યાં કઈ લેવા દેવા છે એલિમેન્ટ સાથે, તો ગયા. ઓકે, તો જેટલા ન્યુક્લિયાઈ હજી ડીકે થવાના બાકી છે એની ઉપર આ રેટ ડિપેન્ડ થાય. So delta n by delta t, that is the rate of decay, or we can say the number of nuclei decayed per unit time, that directly proportional to number of undecayed nuclei in the element. Now if we take limit delta t tends to 0, then we can write this delta n by delta t as dn by dt, that proportional to n. So this dn by dt, the rate of decay, that we can write equal to minus lambda into n, where lambda, this constant here, that is called radioactive decay constant. That is called radioactive decay constant. And why here the negative sign is introduced? Because with time, the number of undecayed nuclei, n, that continuously decreases. Okay. Now see here. From this equation we can write, take this n on left hand side and dt on right hand side. So dn by n equal to minus lambda dt. Now integrating this equation. So integration dn by n equal to minus lambda integration dt. Now suppose at time t equal to 0, the number of undecayed nuclei in the given specimen, that is n0. And we considered at time t the number of undecayed nuclei in the specimen, that is n. So here limits, on right hand side we can take 0 to t, and on left hand side we can take n0 to n. Now integration 1 upon n dn, so that is ln n. Here limits n0 to n, and integration dt, that is t, and limit is 0 to t, so simply you can write that is t, so minus lambda into t, right hand side. Now here on left hand side, if we substitute the limit, then first n equal to n upper limit, then minus n equal to n0 lower limit. So we can write ln n minus ln n0, that is equal to minus lambda into t. So we can write ln n upon n0 equal to minus lambda into t. So simply we can write therefore n upon n0, that is e raised to minus lambda t. So n equal to n0 e raised to minus lambda t, and this is called law of radioactive decay. And here we can observe this thing, the number of undecayed nuclei that decreases with time exponentially. So if we draw the graph of number of undecayed nuclei versus time t, then the graph will be as shown in this figure. It decreases exponentially. Exponentially means initially rapid decrease will take place and then after slowly. Clear to all of you? Now suppose here the decay rate that we represent by capital R. Then we can say the total decay rate capital R of the sample, that is nothing but the number of nuclei disintegrated per unit time we already discussed, or we can say per second. And the number of nuclei disintegrated or decayed per second, that is called activity. That is called activity. So we can write the activity that is equal to minus dN by dt. Here negative sign represent this thing. As time increases, the activity decreases. Clear? Now we have the equation n equal to n0 e raised to minus lambda t. So if we differentiate this one with respect to time t, then dN by dt, that is n0 e raised to minus lambda t, and of minus lambda t, that is minus lambda. It implies that now we can write R that is equal to minus n0 e raised to minus lambda t into minus lambda. So R that is equal to lambda n0 e raised to minus lambda t. Okay. But when here we write n equal to n0 e raised to minus lambda t, then this n0 into e raised to minus lambda t, then we can replace by n. Okay. So R that is equal to lambda into n. Clear to all of you? Any doubt in
Sir.
this one? Or we can write when R activity, that is lambda into n, where n that is number of undecayed nuclei at a particular instant, and R that is the activity at a particular instant. Now from this particular equation we can write the initial activity, that is lambda into n0. Clear? Lambda into n, that is the activity at a particular instant, then lambda into n0. N0 is the number of nuclei at time t equal to 0. So this lambda into n0, we can write initial activity. So we can write R equal to R0 e raised to minus lambda t also. Clear to all of you?